50, yeah. Or 1 divided by 100. Okay? Each one teeth here, 100. Each one here. If here 10,000. Okay? It's ratio. Okay? It's ratio. No, this 1 and this or this 15 and this 1500. No, ratio. Maybe this 1 and this 100. This 1000. This times 15 times 100. 100,000. Okay, depends. Any question? Do you need this? Okay, take your time now. Design a foundation for stability in marine environmentals or turbine, given turbine mass 300 kilogram and gravity 9.81 or 10. If you need it, you can assume it. Okay? 10 or 9.81.
Well, 10 and the sea level is 10.
Yeah, it's 10. No problem. You can assume 10. Okay? Because maybe it's not given. Because these examples, design examples. Okay, and your designer should be known this standard 1.225 or 10 or 12. The wind speed 12 standard. Okay. Now calculate the weight of the turbine. Weight equal mass times G. Weight, we have the weight. We have the mass. Okay, we can convert the mass to the weight in Newton. Mass in kilogram.
And
Multiply by gravity to get the weight in Newton. See, the weight is different here. Not the same if you want to purchase 1 kilo tomato or anything, is a kilo. No in Newton. But here, the weight in Newton. The unit in Newton. While the mass in kilogram. Okay? The units is very important. The mass in kilogram, the weight in Newton.
Yeah, because if you want to like kilogram time meter or seconds squared,
So here the gravity meter per second square, and here kilogram. So kilogram times meter per second square Newton. Any question? No? stand, okay. Wind turbine or wind speed 12, blades radius 45 meter. Okay. Sure, blades can withstand aerodynamic loads. We have loads on the generator. Okay. So now we have formula for the force F equal 0.5 CDA rho V square. You can assume CD 1 not given. You can assume 1. Rho not given 1.225. You can assume 1.225. Okay, so area pi r square given r here. So area is 1. So the force
CD is force coefficient. What is CD?
drag
Coefficient.
coefficient.
Yeah.
Drag coefficient. Okay, and CP
CP
Power.
coefficient.
power coefficient. Okay, C. We have CD and CP. Just okay. F equal 0.5 times 1. This one. Area. Rho. Velocity. Square. Okay. Yes, sir.
You said if we're not given area, then we can assume the radius, or
You can assume area 75 or 70, 60 is fine, but here given radius is given
okay,
45, so we cannot assume,
okay,
okay? We can calculate it, but we assume CD unity and rho already rho is constant 1.225, okay, or 1.23 is fine. Any question? But remember, question for the exam includes 2 or 3 examples today. I will combine 2 or 3 examples together. I will give you more examples next week also in the review. Sorry. Yeah, sorry.
You already on Canvas?
So-
Yes.
Yeah, I already campus last week. I uploaded last week.
Okay, you want us.
Okay. And today, lecture for today, just I want to finish these examples. I will give you another 12 weeks. I will post it to the campus to the course. So now. This is not required for not required. But this is required. Yeah, Mark. Example 8, not required.
Yes, it's not
Yeah, this is because it's just explain, no, not required. But example 9. Example 9. Design a cooling system to prevent overheat. Sure, we need cooling system to prevent overheat during summer or during any time or during the heat generated due to the friction of the rotor. Okay, so we need cooling system. So calculate the heat dissipation, heat equal power output, see here, power output, P, times 1 minus efficiency. The power output given 800 kilowatt, efficiency of cooling 0.8 or 80%. Okay, see, this is efficiency of cooling. No, for the turbine. For the turbine, you can assume if you need the efficiency of the turbine, you can assume it 95. Okay, if you need it. But here, the efficiency of the cooling system, 0.8. So 1 minus 0.8, 0.2. So the heat generated 160,000. Okay, and what? Because this is thermal power. This thermal power, power and watt. Okay, thermal power and watt. But the unit is very important. If you mention to the unit, I will give you minus 10 for each unit, for each miss unit. Okay, if you miss any unit, minus 10, minus 10, minus. It's very important. The unit. Okay, here, watt.
We use in what?
In what?
Two. No, never mind that.
Yeah. In what? Why? Because this is thermal power. Okay, thermal power, so give it in watts. Thermal power, you can also, the thermal power on the resistor. Okay, yeah. Or thermal power and inverter also, and thyristor, or an transistor, or any power electronics devices. Okay, all these thermals power added to this one, but is nothing. Is just 1 or 10 watt, 100 watt maximum. Okay, but here 160,000 watts. Okay, so all these thermal heat is neglected with respect to the heat of the cooling system and the rotation of the motor and blades due to the friction and other effect on the
So
heat.
there is no 100% efficiency, right? Impossible, right?
No.
For that. Because there will be no heat
Yes.
dissipated.
So, I mean, the heat is 0. Okay, I think this last example, just this is explained, is not required for, okay, evaluating noise reduction is not required. Okay, noise reduction technique is okay, so 10 and 8 not required. Okay, not required. Any question? Do you want to take now 10 minutes and then continue? We will discuss after the break fast decoupled load flow and power flow from the wind power to the system. How to, if we have wind turbine here, we have power equations, right? 0.5 C, E, area, velocity, cubic, rho, okay? This to calculate this one. And here if we have generator and load, we will calculate how much the value of power flow in this line and the voltage at this line before and after connection with generator. We can use Gauss seidel, neutral option, or fast decouple. We will use just fast decouple because it's fast and easy solution. But maybe I will ask you about the system consists of 3 bus bars, not 2 bus bars. We'll discuss after the break. Just take 10 minutes, then we will continue with the other topics. I will write the lecture note. Also, I will upload the PowerPoint to the e-course.
What's up?
What's broke?
What's nice?
No, answer
Yes.
your question.